us our first step into the world of statistics. This video is going to take a look at pictograms, probably one of the easiest ways to tabulate data and put it together. In statistics, we need to be able to represent data, basically numbers, in different ways. Why? Well, when in life, when we're given data and numbers to people to look at, when you've got high levels of that data, it can be quite difficult to interpret. For instance, if I had 1,000 results from a survey, I could show that to someone and say, this is a rating of 1 to 10 on whether they liked a program, and then make them look through all those 1,000 results to have an idea of was the show liked or not. But skimming through all 1,000 numbers might be very difficult, and unless there's an obvious trend towards something, it might be even harder to work out how much people liked it or not. So if we can then represent that data in the form of a table, in the form of condensed figures, in the form of a diagram, it's easier then for people to look at it and tell whether the show was liked or not. One of the problems with it is that data can be misrepresented either by incorrectly presenting the data, and that is not necessarily working it out in the wrong way, but presenting it so that it looks different. For instance, there are two measures called the median and the mean, which we'll come into later on, but the median is the middle result, the mean is what we call the average. And if I said the mean with 1 is 5 out of 10 and the median is 8 out of 10, you'd think maybe, oh, the 8 is higher than the 5, therefore the 8 one is better. And that's not necessarily the case. Similarly with pictures, as we'll see when later on, in diagrams such as bar charts, pie charts, and the ones we're doing today, pictograms, it might be presented in different ways to make it look better than it is. And it's often this sort of thing is done by media, sometimes in politics, probably a lot in politics, to make us misinterpret results and to make it appeal to the average Joe blogs. So let's get on with looking at pictograms then. Basically, a pictogram is using pictures to represent data. So for instance, when I'm looking at this pictogram by here, there are the 4 categories down the left-hand side: apple, banana, grape, orange. It's given me a little key as well. It's often found where one apple maybe represents one person, but it doesn't actually tell us here what the apple represents numerically, which we should have. So maybe not such a good pictogram. But say, for instance, we interviewed people and asked them what their favourite fruit was, and then we used a picture to represent that. In this case, they've done one for an apple, one for a banana, one for grapes, and one for orange. And we can see that there's 6 apples, 6 people liked apples, 4 people like bananas, 3 people like grapes, and 5 people liked orange. Simple enough. With this one, it's a bit better now because at the bottom we've got a key. So where the arrow is pointing, you can see that one circle represents 2 Smarties. And you can see why that's important, because if you look, for instance, at the green, you can see that there are actually 3.5 pictures in that diagram. So what I'm going to do is multiply the 3.5 by 2, and that shows me that there are 7 there. So we can actually use a part of a shape to represent a fraction of the number that each shape represents. In this case, half a Smartie is being used to represent 1, because half of 2 is 1. The only trouble with this method, the maximum you could probably go down to is quarters, because once you go below a quarter of one of these pictures, it starts to get quite confusing of how much that little sliver of picture represents. So the most you'll see is a quarter, or the least you'll see is quarter of a shape. So but all I do is divide this by 4. So if I had a quarter of a Smartie here, 2 divided by 4, a quarter represents half. Or maybe if I had 3 quarters here, I'd find out what a quarter is. 2 divided by 4 is a half, and then multiply it by 3. So 3 quarters would represent 1.5. The other thing to notice about this table is we've actually got what we call the frequency at the end. So rather than just leaving it with the number of pictures, we've then written down how much these pictures represent. So we've got 2 ways we can look at this data. As the data was collected, the pictures are probably put down, and we can look at that and see which one goes across the furthest, and you can see the yellow. But as well, if we wanted numerically to play around with that data and to make calculations, we've got the number that those represent on the right, and you can see that 11 is the highest. And that's about it with pictograms. Just remember that we need a key down the bottom, which tells us what one picture represents, and we can have fractions to represent part of that. In this case, we've used half of a Smartie to represent 1 because half of 2 is 1.